I'm Fabian Bravo. I work at Whitestack. I'm a software engineer. At the backend is helping me Alejandro. And we have prepared this presentation about monitoring to VNFs. So with Gianpietro, you saw about Grafana and how to monitoring the orchestrator itself, but not how to monitor the VNFs. And some of you, some hackers, are cheating because I have seen you marking yes at beams metrics at Grafana. I don't know if you went ahead and saw this presentation before, but now we're doing that session, so maybe you're too much in the future. Here it's just the morning. So anyway, let's go ahead. What is the current state of the architecture and features we are offering to monitoring metrics? We have a few main components. The first one is MON, that covers the basic use cases with a solid architecture to expand them easily. Opportunities to enhance that usability. MON is a very important model that takes care of collecting all the metrics that your VNFs are generating, or even the beam metrics that you can get, and talks with Paul, that is the next model, that this design around the auto-scaling use case. It covers the alarms, and it generates, for example, an alarm to auto-scale a VNF, and it takes care of all the policies. That's why it's called Paul. It's the policy manager. All this information is in the descriptor that you can modify, and you can configure all your VNF to work with these modes. For example, to avoid, for example, if you are generating too much traffic to a VNF, you can auto-scale and avoid crashing all the system. And then next is the model PLA that provides computation of optimal placement of NFs over beams and consider cost of compute network. So using the metrics that MON is generating, the alarms that Paul is managing, you can integrate everything to achieve the most cost-effective architecture for your infrastructure. And all of this is possible because we are storing all the data in Prometheus. The Prometheus is a time series database. It's very reliable. Maybe you all know this database. And OSM is using it extensively. And Grafana, you already saw Grafana. Grafana is a great tool to visualize all the data that we are storing in Prometheus. It integrates seamlessly with Prometheus. And as the presentation said, it's a great tool for enhancing usability of the system. And optional, we have the ELK. And there you can put the metrics or traps that you're receiving from your VNFs and search using all the power that Elasticsearch has. But this is optional. So how does it work? The MON architecture is not so simple, but I will try to explain it clearly. So in OSM, we're using a Kafka bus to interconnect all these modes. All the parts that MON has, for example, the MON server that is connected to the database, the SQL database we have in OSM, saves all the data about your VNFs or infrastructure, and then it gets all that information and spawns some collectors. For example, if your VNF is alive, then it knows that it's alive because that is stored in the database, and then it spawns a collector to get those metrics. Also, if you are adding a beam, just like you did in the previous session, it will spawn a collector for that beam. Also, this works with wide area network infrastructure and software-defined networks. Everything you want to connect or to orchestrate through MANO is handled by MON. If you want to read more about this architecture, you can go ahead and click this link in the presentation, and there you will see the documents and a more detailed information. Don't freak out. This can be explained. So how does it work now with all the steps that MON follows to collect the metrics? So first, there's a metrics collection primitive. We will see that in the demo. So this is not magic. And talks with the LCM. The LCM is the model that is the lifecycle manager, and it sends the primitive to the VCA, that is the controller for your VNFs, and it arrives to the VNF, so we can collect all the metrics through MON. MON works as an exporter for Prometheus. Prometheus connects to MON and gets all the metrics through MON. And MON is continuously looking for active VNFs connecting to the database. And then you can connect Grafana to Prometheus. Also, this is the path that the metrics follow until they are stored in Prometheus. And also we have automatic dashboards. So when you are getting metrics, MON creates a dashboard in Grafana just for you and for the NS that you are deploying. So you can easily look at the metrics you are collecting from that VNF, that particular VNF. And also, this is a continuous job. It goes continuously to Mongo to check if there's a new VNF or there's a new network service, and then deploys the dashboard to Grafana. So here it's an example descriptor where you can see some metrics that you can get from the VNF, and this works with the VNF you already deployed at the previous session with Jan-Pieter. And here you can see that, for example, we can get the CPU, the memory, the packets received, the packets sent. Maybe for traffic usage, for each individual user, it depends because it's hard to put them in this descriptor. But for the general metrics, it's easy to put new parameters, new monitoring parameters here. And there's a few details here. For example, you can change the aggregation type. And here we are looking at the average. But you can zoom them. You can change this aggregation type. And well, as I said, Prometheus collects the metrics. Here are the metrics that you can get from the VNFs or the infrastructure. So from the infrastructure, you can get the beam status, as you saw in the previous session. Also, you can get from the VNF, the particular VNF, the VM status, the CPU of the video, the memory, the packets, and this is new just for OSM-8, the snmp metrics, and you will see we will work with a second demo, so you will get not only one demo here, you will get two demos. And all these metrics are stored in Prometheus. So, new features that now we have at OSM. Yeah, in OSM-7, it was possible to collect metrics from the VNF, yes, or from a specific video. Yeah, that is still the same in OSM-8. We're adding a new way to collect those metrics, so just wait. You're getting ahead of me. So new execution environments. We are adding this to OSM-8. This is a new way of interaction between OSM and VNFs. We are using Hmcharts to manage dependencies and new companion pods. So we are allowing vendors to put new companion pods that helps OSM to communicate with the VNFs. For example, one of those is the snmp exporter that Prometheus offers. And we are putting it alongside with the VNF, with each VNF. And also, we are allowing vendors to create new primitives and through a new API that is fully flexible and can be customized for each VNF if the vendors wants. And this allows to new primitives for day 0 or 1 configuration, even if day 2 configurations. So what are these new execution environments? If you take apart the VNF, each VNF will have this execution environment, just if the vendor or you want. And inside, we can put these companion pods like the snmp exporter. This is all the architecture for the snmp metrics from the VNF that we are showing just now for you. And we are putting, if you are familiar with the snmp protocol, the MIP files and the generator YAML that Prometheus needs, and also a Hmchart that deploys this snmp exporter inside the package that is bundled with the tools that you already saw in the previous session. It goes to the NBI and it is stored in OSM. Then the LCM loads the job for Prometheus just to communicate the snmp exporter and the VNF and store those metrics directly without passing through MON. And you can configure this using the new API directly to the execution environment. So this is a new architecture that is flexible, and you will see that this can be used for not only metrics, it can be used for artificial intelligence that you can put like grabbing the VNF. So you can grab the VNF with all these tools and companion pods to make it easy to manage the VNF. Maybe you can create a new companion pod to check for the traffic usage per user, for example, and charge them. So now let's go to the demo. This is something that was previously done, but anyway, if you already done this exercise, okay, just hear me. You can just see the demo, but if you're not, this is a useful example to get the metrics from the VNF. So I need you to completely, okay. So if you are ready with the previous session and you have your package, that's fine because we are going to modify it. So I really need you to have that completely finished. Okay, let's go then. So we have the VNF package created in OSM, and we need to do some changes there. Okay, it's a lot of text, but if you look at it, it's just YAML, and we are creating these 4 metrics that we are going to get from the VNF. The CPU, the memory, the packets received, and packets sent. So let's copy this. Let's copy this piece of descriptor and put it in the line 8. I will show you. Remember, you can copy this from the presentation that is pasted in the chat. Okay, I'm going to cheat a little bit because I'm going to use Visual Studio Code. That is awesome. Gianpietro already did some marketing about it. I'm going to to stress this out. It's awesome to work with YAML. It's awesome to work with Python, especially we're using Python in OSM. So copy this piece of descriptor and put it below the line 8. So at the VNFD level. So let's go to OSM, enter with your credentials, and let's edit the VNF package. Yeah, you can use OSM-MANO dashboard. I know you want it. So let's go to package, VNF packages, edit, and we have this nice editor to modify the descriptor. So we put the monitoring params below VNFD, just like I did here. So if you already paste this, check the indentation, because remember, YAML, it's aware of the indentation. So this needs to be below VNFD. We're right there. And all the IDs for the metrics you want to monitor needs to be below monitoring param. Okay, if that's right, let's go ahead and go to the next step. So we need now to put the monitoring params inside the VDU. So what we did just now was pasting the metrics that we can use for each VDU. Now we are telling the VDU to use those metrics. So if you have several VDUs, you can refer to those metrics through this piece of descriptor. So I'm going to go ahead and cheat again and use Visual Studio Code to copy this piece of code. You can do this using the dashboard, so it's easy. So here at the VDU level, put this piece of code and check the indentation, because remember, YAML is indentation aware. And everything seems fine. Okay, if you do this right and you're happy with it, hit the update button. Okay, if everything went well, you will see that green message on top of the dashboard telling you that everything went well. Now we are going to destroy the NS instance you created before. Don't fear, because it's easy to manage the network services that you have, or the VNF. That's why it's the orchestrator. And we have the orchestrator, because with OSM it's easy to just redeploy all your network services and VNFs. So we're going to delete this. You can just hit here delete. It says force delete. I'm kind of fearful of that command. Or delete here. You can just click the button and put OK. And OK, we need to wait a few minutes. Remember, don't fear about we are deleting the entire network services, because with OSM it's easy to redeploy all of this. And you can do it through your command line. So we are here, and you can go and use OSM-NS list. I just deleted my NS, but you can then copy the ID that you can see here and put NS delete and the ID. Anyway, I did that just now with the dashboard, and the dashboard is so easy to use. So use the dashboard. Anyway, we need the CLI now, because we are relaunching our VNF, our network service, using the command that you saw before. That is this one, OSM-NS create, using your tenant ID there. For me, is the 59, just to know which one is ours. So let's go ahead and relaunch the NS, just like we did in the previous session, and we are doing now. Let's do that. Okay. This is like those kitchen TV programs where you have pre-baked something. I always wonder, how do they cook so fast? Well, they have everything done previously, so. But when you're a kid, you're, what? They have everything done already. Okay, we launch again our NS, and let's check it out here. So if you go to NS instances and you refresh, and let's wait. It's relaunching the NS now. So if you see those green checks here, then you can write yes here. Maybe it's kind of slow because all of you are doing the same as me, I think. Okay, the green checked. So everything went fine. Now we have our network services just as before. There is no difference about it, except that now we are monitoring it. And how we can tell? Because now you can click the metrics button. I know some of you already did, but now you can click it with confidence. And we have this dashboard. Okay, it's kind of empty, right? It's because it takes some time to collect the first metrics. Maybe it can vary, but maybe it can be 5 minutes. But it takes some time to get the metrics, but you can see the dashboard now. Okay, if you saw that screen, now it's a success. This is an old meme, but it checks out. Okay, but the thing that I really want to show you is the snmp metrics. We have been working really hard at OSM to have this feature done, and so you can try it right now at the Hackfest. What we are doing is, through the snmp exporter, get some metrics from the VNF using the new execution environment system. So now we are using a tool from Helm. Helm is the package and distribution system Kubernetes has. I don't know if you're familiar with it, but it's really helpful, and it has some awesome features like having a repository, and you can version your Kubernetes descriptors, and you can have dependencies. And so it's really awesome to work with, and to especially to handle this kind of features. So what you are doing, and because we work at Whitestack, we have prepared a new repository with the execution environment you are going to use right now. So let's go to the terminal and add the repository from Whitestack and update it. So let's go to the CLI. Here we are. And add the repository from Whitestack. So helm repo add. You can put the name you want, but it's Whitestack, so we are naming it Whitestack. HTTP helm.whitestack.com. Okay, now you have Whitestack at your repository. Nice. Now you can write helm repo update, and now Helm greets you with this update complete, happy helming. Okay, what we did is to add the repository, and you can check it out. For example, you can put helm search repo, and you can check that the package is there, and you can install it. Okay. If everything went fine, you have to see this if you put helm search repo. Has snmp replaced SSH method used? It's not replaced. You can still use the old method, but this is a new way to interact with snmp. The main idea is that Prometheus already has these awesome exporters, so why we are not using them? So that's why we are using the official Prometheus snmp exporter to go and get those metrics. Yes, and this only works with the OSM Kubernetes-based installation. But good for us that the OSM that is installed and you are using is the Kubernetes one. Okay, if you're looking at this at your terminal, we are good to go, and let's go and with the next steps. So go to your package, the one you created with Gianpietro at the previous session, and create a new folder named Hmcharts. So we're going to do just that. So we go to Magma and Hackfest, VNF, and in that folder we are going to create the folder Hmcharts. Okay, there it is. And inside it, we're going to install the execution environment. how we do that? With this awesome command from Helm that fetches the chart and install it in that particular folder. So let's go ahead and do that. So Helm fetch, we put the repository we're referring and the package that we want to install, the eechart. It sounds like magic, and with the option untar, because if you don't put that, you will just download a target setter. Okay, and if we look now, there's a folder called eechart. Nice. If you look at that folder, you will see that there's the chart YAML, the charts, a Prometheus job template, values YAML, templates. If you go to templates, you can check that there's a lot of YAMLs. Those ones are for Kubernetes. And a lot is happening now. I don't want to go to detail right now because for the demo, we just need a few tweaks here. But after the demo, we can explain very detailed what everything is and why it's there. So in the eechart folder, we're going to edit the values YAML. The values YAML for a Hmchart is where everything is configured. And we need to edit at the bottom of that file the snmp exporter. It says snmp exporter enabled, false. We are going to enable it, putting true. Just that easy. So in the values.yaml that appears in the eechart, we are going to modify it and put enable true. Just that.
Which file is that? Can you please repeat?
Yeah, it's the values.yaml that you can find from the eechart folder. Inside the eechart folder, there's the values YAML.
Yeah.
It's like the point for the execution environment. It's where everything is configured.
Okay.
So let's do it again. At the bottom of that file, you will find snmp exporter enabled. Just put true. And that's it. So now we go back to the magma folder, and we are going to recreate the packages that you already created. I think this is kind of repetitive, but if you repeat this enough, you will be an expert about creating packages for OSM. And we are using, okay, this is the last line. Okay, so this is done, right? You can just put yes in the chat or talk, open the microphone a little bit. Okay, thank you. Okay, if this is done, we need now to add a few more pieces of code in the descriptor. This is easy. It's just a piece of code that references our new Hmchart, the execution environment, and the metric service. Here you can see that we are using the metric service snmp exporter that we just enabled in the values file. And the connection point ref, this VNF management, is the connection point that you already find in the descriptor. You can find this reference in your previous descriptor. And there's something strange here. it says initial config primitive. As I said, you can put new primitives or functions that you want to execute in your VNF for day 0 or day 1 configuration. This is a day 1 configuration that we are enabling snmp for the just deployed VNF. And here it is, the config primitive that we are using, and it is named generate snmp. We are going to explain this after the demo, so just wait. But now this is the piece of code that we need to put. Now, to avoid mistakes, just in the previous step, you can just go ahead and copy the descriptor from the same machine. So let's do that. So the only difference between this YAML and the previous one is that this YAML has the descriptor, the piece of code that enables snmp for this VNF. Okay, if everything is okay right now, don't be scared about this screen with lots of comments, because I'm going to paste them to Slack, so fear not. We are going to delete the previous packages. You can go to the OSM dashboard if you like. Let's,
When we do the NSD delete, it says at least one NS is using the descriptor.
Yeah, because you need to destroy your instance. First, delete the instance that we were just so happy because it deployed. Okay, bye-bye. Remember, it's easy to redeploy network services and VNF, so fear not. Once it's fully deleted, you need to delete your packages because we are going to create them again. So, okay, it's still deleting the instance. Okay, now it's clear. Now it's gone. So I had the same error that you had, because it was,
I think it went away after some time.
Completing the process. Yeah, it takes some time, but it's not long enough. Okay, now that we are empty, oh my God, so empty. Let's create again the packages. Now we are using a different method because we need to make sure that the new execution environment is inside the package. So we are going to use this star to make the packages. So we already delete our previous instance and packages. This is just an example. If you are doing this through the CLI, list the NS, then you need to put here the ID that your NS has in that list. And then delete the packages through the CLI. Okay, if that is already done, we can go ahead and create the new packages. If you have any problem deleting the packages, just tell me or tell Alejandro, and we will be happy to help you. So let's go and create the first package, that is the VNF. Before copying those commands, you need to be in the magma folder. So please go ahead and make sure that you are in the magma folder. You can write pwd and check that we are in the magma folder. Once there, let's create a VNF package. Okay, everything went fine. Let's check. Yeah, it's there. Let's go with the NS now. Okay, check with LS, everything is fine. And now we upload those packages using the OSM upload package. This is like we are manually doing this instead of using the package create that Gianpietro used in the previous session. Okay. And okay, if you see this ID, everything went fine, and you can now go to OSM and check that your packages are there. Okay, everything is fine. I forgot something in the VNF. Or not? No, everything is fine. Okay. As you can see, we have the NS package and the VNF package. Excellent. So right now the magic comes through, and we finish this with the usual command that you already know and you have repeated so many times that you have to write it from memory, I think. So let's go to the terminal and let's launch our new NS with the power of a new execution environment. Okay. Remember to use your tenant number in the NS name, so we are not confused in the Grafana or Prometheus values. If you're in Magma, just like I did, remember to be positioned in the folder where your params YAML is. With my params YAML, yeah, it's my home directory. Okay, if everything went fine, you will see at your OSM dashboard that the NS instance is working, is processing. So right now we are instantiating the same network service, but now with execution environment and with Prometheus and snmp metrics. So we have to wait. I don't know if you have any questions so far.
One question regarding the snmp method. In SSH method, there was a 5 minutes interval between the matrix retrieval. And as far as I remember, the snmp method was about to be free of this limitation, which means that the metrics should be collected more frequently than 5 minutes. Has it been improved or is still 5 minutes?
Yeah, again, you're going ahead of me, but yes, now you're free of those intervals because you're working directly with your VNF using the snmp exporter. So anything that Prometheus can do with the exporter, you can do it right now with OSM. It's the same exporter. But yeah, thank you. So I think we're almost ready. It takes some time, especially because you are doing the same exercise like me. The servers are really stressed out. But they are machines. They don't complain, right? Maybe that's why Terminator happened. We're stressing out too much these machines.
May I ask another question? Related to snmp. This is really big progress, a step forward. But I'm curious if you also improve the monitoring of scaled out videos. if we had a number of access gateway, for instance, and based on the metrics value some, well, the first one has been scaled out, then the second one was scaled. Okay, we get a number of videos, right? So do you still monitor the first original one, or every single video instance is monitored independently?
Okay, that's kind of a limitation right now for SNMP, because we are just putting the metrics to Prometheus directly, and we need to put like a prefix to differentiate between VDUs, for example, or different VNFs. But this is the first version. And for the MON metrics, it's per VDU. If you look at the descriptor, you will see that if for each VDU, we need to put the params that we are getting from the VDU, that particular VDU. And you need to do this for each VDU that you want to monitor. I don't know if that answered your question.
Actually, yes, but the point is that, okay, you can specify the parameters for the master VDU, the original one, the first one, right? The replicas of the original VDUs are not specified anywhere. So you have to, let's say, define them by adding suffixes, prefixes, and so on, right? Yeah, but for real scaling operation, my opinion, every VDU should be monitored independently. So every VDU which is scaled out may have different utilization, right? So let's say we get 10 access gateways, and one of them is getting like 80% of the load, right? So based on its individual metrics, the decisions should be made just, okay, let's scale it out because okay, it's consuming 80% of resources, right?
Yeah.
And also, if the other way around, if the utilization of a given access gateway is less than like 10%, we may make a decision, okay, we don't need it anymore, so let's remove it, right?
Right. Yeah, I understand your question. And this is a description of a, not for an instance of a VDU. It's like in programming languages, it's like the difference between an object and a class. This is a type of VDU, and if you look at it, you can put the number of this VDU I want. So this monitoring params will work for this class of VDUs, this type of VDU that is described here in the descriptor. So it will work if you scale in, you scale out, because these are using this VDU. It's not like this is a master VDU. This is like the recipe to make this kind of VDUs. Right? I don't know if
but you will, in Prometheus or Grafana, you will just see only one VDU. You won't see the scaled out replicas, right? I mean, the metrics.
In the metrics, you can change the dashboard. This is something. This is the automated dashboard, but you can modify it, and you can use these metrics to scale in or scale out using the alarms in the policy manager. So everything is covered, at least for these kind of metrics.
But I meant the other thing. If you get like two access gateways, right, with two, okay, everyone has a management interface, different separate management interface. Will OSM send SNMP queries against every single replica of access gateway, or just the first one?
Okay, it's for the VNF as a whole right now. So it doesn't matter how many replicas, it's talking with the VNF as a whole, the complete system, if we can say it. So maybe this is a limitation right now, but this is the first step towards the SNMP collection and use of those metrics in OSM. I don't know if you want to know more about this. We can talk in Slack, and maybe we can improve this feature. Remember, this is the first version, and all the feedback that we can get, it's really valuable and awesome. So if you can leave it in Slack, write it down, it will be really helpful.
Okay, because I know the problem. I'm fine with your answer because I already submitted some questions in my case study for OSM-7 related to monitoring and scaling. So now I know that let's say the metrics retrieval has been changed from SSH to SNMP. There is no 5 minutes limitation, let's say, but some other, let's say, features are still to be developed, like monitoring every single video independently. I mean, every scaled out video independently and so on. So I'm fine, thanks.
And really, your feedback is really valuable, and write it down because we are still working on this feature. Okay. Right now we have the green light. I don't know if you have the green light too in your dashboard. It took some time, but right now it's green. And now we are going to use Prometheus. So copy the IP that you're using for the dashboard and put it here in a new tab at your browser. I'm using Firefox. I like Firefox, but if you're using Chrome or even Internet Explorer, I think it's called Edge. But if you're into that, I'm no one to complain. Okay, put the IP, and the port is the 9091. Go there. And first, we're going to check the health of this. And as you can see, a lot of you really achieved the SNMP exporter because all this is up. All of them are exporters that you are using. You just created. One of those is mine. I don't know which one, but anyway. Now, if you go to graph, you can check that we have some SNMP data here in Prometheus. I always want to test. I always test with if in objects you can execute. If you can see, we have a lot of data here, and you can graph it. So right now we are seeing all the network services that you deployed. I'm so happy that you achieved this. Nice. So if you are seeing this one, you can just go ahead and put yes in the SNMP metrics. It's that easy too. Maybe the explanation is longer than the demo, but I think it's better designed that way. So you win a meme if you complete this task. This is an old meme too. I don't know if you are familiar with it. So great work. Everyone here is a hacker. Okay, before ending, I'm going to explain what just happened because maybe it's too magical, and I don't want things to be magical. Yeah, how you can find your own SNMP. So if you go to your NS instance and VNF instances, you will see that there's an identifier. If you check the identifier. For example, mine starts with FA42. 42 is a really nice number. Remember the answer to everything. Here is my, oh, it's the lowest. Why? I'm losing this battle. Okay, here's my snmp exporter, but the snmp exporter has your VNF ID there. You can find it because it has the same ID. And in the graph, it's the same. So if you search for your VNF ID, you will see there your metrics. Nice. So everyone has the snmp exporter installed. Now we are going to explain what just happened because it's too magical. I don't want things to be magical, especially in a presentation of this awesome feature. So what we did is installing a new chart, and Helm is really awesome for this because you saw it. It's really easy to install new things in your existing package. And if you're familiar with Hmchart, it has all the YAMLs that render your Kubernetes deployment. For example, you can see here the ingress, the service account, and the stateful set. The stateful set is the one that deploys the execution environment for you. It's kind of ugly, but it works. It's ugly because this is a template engine. If you look at this, for example, it says values.snmpexporter.enable. And if you remember a few steps before in this demo, you have to put enable true, right? So if this is enabled true, this deploys with this piece of code enabled, and if not, it just deletes it. And here, for example, there's a folder that says source, and it has a VNF execution environment.py. Remember that, I don't know if you remember that in the descriptor for this execution environment and the snmp monitoring, you saw that something was called generate snmp, and I told you that that was a day one primitive. Do you remember? So here it is. You can, especially if a vendor wants to create his own package, they can write their own API endpoints and create their own primitives using this one. This connects directly to the VNF. But this one, for example, injects the MIPS and the generator that the Prometheus exporter uses and creates the configuration for the snmp exporter. There are another primitives that you can use. For example, this config connects through SSH and configure the VNF. But we are not using them right now. We are just using the snmp. So this is code that is already done by us, but a vendor that wants to create a new package can create their own primitives and API endpoints just to interact with the VNF. And if you look at the charts folder, there is the snmp exporter, and it's called snmp exporter. And there we have the MIPS, the generator.yaml. If you look at it, you can see that we are walking through the interfaces OIDs, And that's why we could get the if in octets. Maybe you're not familiar with this way to describe the OIDs and the SNMP configuration, but this is how Prometheus does it. So we are not reinventing the wheel, and we are just using the SNMP exporter from Prometheus. And here are the templates, exactly like you saw for the execution environment. We have the templates for the SNMP exporter to deploy. This is just Kubernetes stuff. We are deploying the SNMP exporter. Here is using the template, but if you look at the values YAML for this exporter, you see that is the prompt SNMP exporter. It's the one from Prometheus. So here we are deploying the SNMP exporter. And just like that, a new vendor can, for example, add telemetry if they want. Just put a new folder here in charts and put telemetry if they want, and deploy the VNF with the telemetry compatibility now. It's that easy. But this is using Helm, so maybe this seems weird because it's not the exact syntaxes like or it's a syntax like Kubernetes, because it has these weird things. But this is Helm, and you can be familiar with Helm. Going to Helm, if you look it at Google, helm.sh, and you can make the tutorial or get familiar with this kind of technology. Really, it's really awesome, and that's why we are using it for this new feature. Anyway, this is the first module or pod that we are deploying alongside with the VNFs for this particular feature. But there will be more in the future, and you can help us and contribute with more pieces here or more charts we can add to this execution environment. So the last piece of this puzzle is the Prometheus job template. This one is the one that injects the job to Prometheus. The target that you saw in Prometheus is created by this. So in the job name, we are putting the VNF ID. It's a ID constructed using the VNF ID that you saw in the OSM dashboard. And all these things are data that Prometheus needs to connect directly to the VNF. So that's it. And finally, we have the values YAML that controls everything. So I know that SNMP exporter is here, but it only works if we are putting enable here, because we want to make things easy for you to work with. Thank you. This is the final session, so let's meet again tomorrow for the next sessions. And happy hacking. Welcome to the Hackfest.
Thank you.
Okay, thank you. Many thanks.
Thank you.
Thank you. Bye.
Thank you, Fabian.
Thank you, Fabian. Bye.